Okay, 2.15, we're asked to find the h5 and h6 Hermite polynomials. I've included sort of the first 5 for reference right here, just so we can sort of look back to it later on. We also have the recursive formula that we've defined earlier in this section for the analytic method, and we know that h, which is what the Hermite polynomials are based off of, is a power series in aj multiplied by y to the power of j. So let's start right away with n equals 5. So if n equals 5, this is odd, so that means we're going to be dealing with an odd series. H is going to be a 1 times y plus a 3 times y cubed plus a 5 times y5. And the series terminates at the 5th coefficient, so there's no a7 or higher. Now, let's start plugging into the recursive formula. So a of 1 plus 2 is going to equal negative 2 times 5 minus 1 of 1 plus 1 times 1 plus 2 multiplied by a1. So this is going to give us negative 2 times 4 over 2 times 3 a1, which is negative 4/3 a1. A of, let's see, this is a3. So 3 plus 2 is going to equal negative 2 times 5 minus 3 over 3 plus 1, 3 plus 2, a3. This is going to give us negative 2 times 2, 4 times 5. The 4's cancel. This is equal to negative 1/5. I left out the a3 right here. a3, and this is equal to negative 1/5 times negative 4/3 times a1, which is going to equal 4 over 15 times a1. And then that is the end of the series because the series terminates at a5. So therefore, h is going to equal a1 times y minus 4/3 y cubed plus 4 over 15 y to the 5th. And then we have the convention that sort of the highest power coefficient has to equal 2 to the power of n. So a1 times 4 over 15, which is the coefficient of y to the power of 5th, which is the highest power, has to equal 2 to the n, or 2 to the 5th, which equals 32. 2, 4, 8, 16, 32, yeah. So that implies that a1 is going to equal 15 over 4 times 32. The 4 and the 32 make an 8 at the top. This is 8 times 5 is 40, 120. So h5, the 5th Hermite polynomial, is going to equal 120 times y minus 4/3 y cubed plus 4 over 15 y to the 5th. So this is going to give, and in the convention of putting the higher powers first, it's going to give us 32 y to the 5th minus, let's see, what is that? 40 times 4 is 160, 160 y cubed plus 120 y. And let me double check that that's right. Yes, that is indeed correct, because if we compare this to h5 from our reference here, that matches. All right, next one. N equals 6. Once again, we pull the same recursive formula from before. And we also know that since this is an even term, we're going to be dealing with an even series. So h is going to be equal to a0 plus a2 y squared plus a4 y fourth plus a 6y to the power of 6. And since n is equal to 6, this is where it terminates. Let's start with a2. So a2 is equal to negative 2 times 6 minus 0 over 0 plus 1, 0 plus 2 times a0. This is going to give us negative 2 times 6 over 2. The 2's cancel. This leaves us with negative 6 times a0. Next one, a4 is equal to negative 2 times 6 minus 2 over 2 plus 1, 2 plus 2, a2. This is going to give us negative 2 times 4 of 3 times 4. The 4's cancel. What we're left with is negative 2/3 a2, which equals negative 2/3 times 6 times a0, which equals, what is that, negative 4 a0. Final one, a6, this is equal to negative 2 times 6 minus 4 over 4 plus 1, 4 plus 2, a 4. This is going to give us -2 times 5 times 6. This is going to give us 1 and 3, so an a4. Whoops. So this cancels out to give us 3, so that leaves us with -2 over 15, and then a4 becomes -4 times a naught. This is going to give us 8 over 15 a naught. So finally, our h term is going to equal a naught times 1, and then subtracted by 6, I believe. There's a mistake here. I added a negative here, so this is actually supposed to be positive. So if this is positive, then this term is going to be negative. All right, -6 times y squared plus 4 times y fourth minus 8 over 15 y to the 6th. And by convention, the final coefficient for the largest power, a naught times 8 over 15, has to equal 2 to the power of 6, which is going to be 64. So a naught equals 15 over 8 times 64. That's going to be 120, I believe, because the 8 cancels with the 64 to make 8, 40, 120, yeah. So finally, plugging this in, the 6th Hermite polynomial is going to be equal to 120 times 1 minus 6y squared plus 4y fourth minus 8 over 15 times y to the 6th. Plugging this in, we reverse the relation as before. h6th is going to equal, let's see, 120, so -64 times y to the 6th plus 480 y to the 4th minus, that's 0, 12, 720 y squared plus 120. And let me just double check that that's correct. -64. Yes, and that is it. Apologies, I just realized I made a slight error here. The convention is not just that sort of this coefficient has to equal 2 to the power of 6, it has to necessarily equal positive 64. So what happens here is that this coefficient here is negative, so what actually is happening is that the solution is supposed to be a naught multiplied by a negative 8 over 15 has to equal 64. So a naught has to equal -120, not positive. So what happens is actually all of these signs have to be sort of reversed. So this is going to be a negative, that's going to be a positive, and this is going to be a negative. So let's just fix that real quick. Minus, plus, minus. And that's the actual Hermite polynomial according to the given convention.